Messy algebra is a topic that a lot of teachers cover in their classes. You can think of this as the pre-calculus. It's usually covered at the beginning of class as a way to make sure that you know your stuff. So if you do badly with this, it flags you as a student who needs some extra help. I must say that this is really stupid. Like, no one would want to do this stuff for fun, and I'm sorry, I wish we were better than that. Math should be fun. Math should be something that you want to do. And sometimes math is taught in a way that makes sense for teachers, but doesn't make sense to students. And this problem is designed to test many things at the same time. So, for one thing, it tests your organizational skills. So how neat are you in the face of something that is messy? It's kind of like being a math janitor. So you can think of this problem as like a knot, and you're trying to untangle it to something that's manageable. And the more organized you are, the more likely it is that you can solve it. And like I said, this stuff sucks. I'm sorry, I wish it were better, I'm not gonna lie. It's a teacher's way of making sure that this is the class that you belong in. But on the bright side, if you get this right, then you should be fine with most of pre-calc, which is why this is problem number 1 when it comes to most review sheets. And the second thing is that it tests you on your algebra, of course. Mostly it's going to test you on your exponents, so you'll see like, how do you deal with this 1/3 and this 4/3? And I'll go over that, of course. Okay, so the first step when you deal with any of these problems is to make sure that you write the problem down correctly, which is something that a lot of students have trouble with. I don't know what it is. When you do something boring, your mind is prone to skipping. It's like your mind time travels half a second into the future. Okay, so we see two terms, here and here. If we look at one of these terms first, we see a 2x cubed minus 1. And I like to do a trick. Whenever I see something like this, I always say, let a equals 2x cubed minus 1. And here the other term is x cubed minus 4, which is represented by b. I do this because it cuts down on writing time. It's just a lot easier to look at this as opposed to writing everything out line by line. So numbers first. I see these 3's are the same here, so I can cancel them out. And then arranging all the variables in order. From left to right, numbers first, then x's, then a's, and then b's. This 3 and this 6 combine to 18. And everything else is followed and rearranged, just like the other term. So here's where we start to factor things out. And it's best to show the work in a separate area. This is just for you to visualize what's going on. So for this 4 and this 18, it's the same thing as saying 2 times 2 and 2 times 9. Here a 2 comes out, and what you're left with is a 2 and a 9. Next are the x's. Here both x's come out. And then for the a's, same thing happens. The lowest term comes out. You're left with just a here and 1 here. This is kind of like saying a to the 3 minus 2 plus a to the 2 minus 2. This one's just 1 and this one's just a. Next are these b's, and this is the real test. So what happens if you have something like a to the 7th plus a squared? So you pull out the lowest term, the a squared, and then you get a to the 5th. But how did you get that a to the 5th? That's the same thing as saying a to the 7 minus 2. So if we generalize this, we pull out the lowest term, which is b to the 1/3, and then on this side we get b to the 4/3 minus 1/3. And of course, 4/3 minus 1/3 is the same thing as saying 4 minus 1 over 3, which is 3 over 3, which is 1. Now we can put everything back. At this point, we're almost there. Just distribute this 2, distribute this 9, combine like terms, and then that's it. So for these other two problems, you should be able to handle them on your own. I've included the work in case you want to check your answers. And that's it. Thanks.